Hello, welcome to Lesson 15, Finding the Distance Between Points on a Coordinate Plane. Before we begin today's lesson, let's look at the steps needed to do so. Step 1, graph the points. Step 2, draw a line between the 2 points. Step 3, draw a right triangle. The line between the 2 points will be the hypotenuse. Step 4, count the squares to find the length of A and B. Step 5, use the Pythagorean Theorem to find the length of the hypotenuse. And notice there's a hint at the bottom. These problems will all be addition because you are looking for the hypotenuse in all of them. So, before we begin, let's look at the Pythagorean Theorem. Remember from previous lessons that the Pythagorean Theorem is equal to a squared plus b squared equals c squared. And the only time that this formula is going to work is when you're dealing with a right triangle. So today in our lesson, when we're trying to find the distance between these two ordered pairs, we're going to form right triangles. And we'll simply count to find the leg lengths of A and B, and then we'll plug those leg lengths into our Pythagorean Theorem. Okay? So let's go ahead and get started with our first example. So we have the ordered pair 1 and 2. So we come over 1 and up 2. We have the ordered pair 3 and 7. So we come over 3 and up 7. Okay? So we've got these 2 points plotted. Our job now is to make a right triangle out of them. I can come over and up. I can go up and over. I'm still going to have a right triangle. So I'm just going to come over and up. Oh, let me try to keep my line nice and straight. Over and up. Okay, this is my right angle. So I know it's going to be a right triangle. And then I would just connect these 2 lines and we have a right triangle. So this is C, and then these 2 sides are A and B. Your leg lengths are always interchangeable, so I could have had A here and B there, okay? As long as C is always across from the right angle, okay? So we are going to be looking for the hypotenuse in each one of these examples today. So what we're going to do is we're going to count from here to here. I'm going to count the squares, or the units. So 1, 2. I have a leg of 2, and I also have a leg of 1, 2, 3, 4, 5. A leg of 5. Okay? Now notice when I don't count until I move. 1 unit, 2 unit, 3 units, 4 units, 5. Do not start counting at the corner. 1, 2, 3, 4, 5, 6. You'll mess up. So what I like to tell my students is do not count until you move. So I'll do that again. 1, 2, 3, 4, 5. 1, 2. So I have my leg lengths of 2 and 5. Now all I have to do is to plug those into the Pythagorean Theorem. Okay? So 2 squared plus 5 squared is equal to c squared. And remember, this is so quick and so easy if you're allowed to use a calculator. So I would simply start off with my square root symbol, and I would say square root, and I would say 2 squared plus 5 squared equals, and it would give me 5.38, which is going to round up to 5.4. Now, why is it going to round up to 5.4? Because we're rounding to the 10th place. We always look back. If the number in the hundredths place is 5 or larger, you bump this number up. Okay? 4 or lower, it stays the same. Okay, but let's pretend that you are not allowed to use a calculator. Okay? You simply have to do the math. 4 plus 25 is equal to c squared. Take the square root of 29. That's going to give you c. And sometimes your teachers will give you a page of perfect squares. I can tell that this is going to be between the perfect square of 25 and the perfect square of 36, which is going to be somewhere between 5 and 6, okay? Somewhere between those 2 numbers. And when we used our calculator, we ended up realizing that it was 5.4. And that proves true. It's somewhere between 5 and 6, okay? All right, not too bad. All right, let's do our next example. Problem number 2. 3 and 4. So you plot 3 and 4. 1, 2, 3. Up 4. 1, 2, 3, 4. 6 and 8. So I come over 1, 2, 3, 4, 5, 6. Up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I have to make a right triangle from those 2 points. So this time I'm going to come over and down. Again, I can tell my right angle is in that corner where it looks like an L, okay? I can put my little square to represent that right triangle, and then just draw my line, okay, my hypotenuse line, and I'm going to be looking, again, for C, okay? How do we find our leg lengths? We find our leg lengths by counting. So my leg length here would be 1, 2, 3, 4. I've got a leg length of 4 units, and then 1, 2, 3. So we've got 2 sides, 3 and 4, and we are looking for our hypotenuse. And remember, our hypotenuse will always be larger than our leg lengths. So I would plug in 3 squared plus 4 squared is equal to C squared. Okay, do my math. 9 plus 16 is equal to C squared, but I don't want to know what C squared is. Okay, I want to know what C is. How do you undo a number being squared? You simply take the square root of it. And this one ends up being a nice, perfect square. So the square root of 25 is 5. Okay, so our missing side, which is our hypotenuse, is 5. And then check yourself. Is 5 larger than those 2 side lengths? And it is. If you ever come up with an answer that's smaller than your leg lengths, go back and rework your problem. Okay, so not too bad. Remember, we're trying to find the distance between 2 points by using the Pythagorean Theorem. -6 and 4, and 2 and -8. So when your x is negative, you go to the left. 1, 2, 3, 4, 5, 6. My y is 4. 1, 2, 3, 4. So I have a point, this time in quadrant 2. Remember, if we would go back and review our quadrants, we go counterclockwise. 1, 2, 3, 4. Okay. So just a quick little add in there for you. So we have -6 and 4, 2 and -8. 1, 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. So this time, the distance between these 2 points is going to be a little bit larger than what we've been working with in numbers 1 and 2. So I'm going to come over until I'm underneath that point, okay? Then I'm going to go up or down. Then I draw my diagonal line, which is my hypotenuse, and I have formed a right triangle. Our job is to count to find our leg lengths. 1, 2, 3, 4, 5, 6, 7, 8. 8 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got some rather large numbers this time. Again, we're still looking for the hypotenuse. Our hypotenuse needs to be bigger than 12 and 8 because that's the rule. So we've got 12 squared plus 8 squared equals C squared. Hopefully you know your multiplication tables. 12 times 12 is 144. 8 times 8 is 64. And then we would add those 2 numbers up. Come off to the side of your paper, do a little bit of math. 4 plus 4 is 8. 4 plus 6 is 10. So is 208 a perfect square? No, it's not. So hopefully, and I feel like you're going to be allowed to use a calculator. So hopefully you are allowed, or at least you've been given a sheet of perfect squares. So the square root of 208 would be 14.4. So the square root of 208 is going to give us C, all right? 14.4. And it was actually 14.42. So if we're going to review our rounding rule, is 2 going to make 4 bump up? No, remember it has to be 5 or larger to increase that value in the 10th digit. Okay, so we have an answer of 14.4. Let's double check. Is 14.4 larger than 12 and 8? Yes, it is. All right, our last example, and we'll wrap this lesson up. Hopefully you're catching on. We have negative 5 and 2. 1, 2, 3, 4, 5, and up 2. Okay, then we have negative 6 and 10. We're still going to be in this quadrant too. So negative 6, 1, 2, 3, 4, 5, 6. Up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, notice we're only 1 unit away from one another. It's going to be a unit of 1, or a leg length of 1. So this right triangle is really skinny, okay? So we've got a leg length of 1, and also a leg length of 1, 2, 3, 4, 5, 6, 7, 8. A leg length of 8. All we have to do is plug those numbers in to our Pythagorean theorem. Do the math. 1 plus 64 is c squared. Is 65 a perfect square? No, it's not. So if we take the square root of 65, we're going to get a decimal. I'm going to use my calculator. The square root of 65 is 8.06. Would our 6 change our 0? Yes, it would. So again, if you're not allowed to use a calculator, you have to think of the perfect squares that this would fall between. So I know that 64 is a perfect square. I also know that 81 is a perfect square. So the square root of 64 is 8. The square root of 81 is 9. So your answer would be somewhere between 8 and 9. Was our answer between 8 and 9? Yes, it was. Is 8 larger? Is 8.1 larger than 8 and 1? Yes, it is, so I know we're right. So thank you for watching our lesson on finding the distance between 2 points, and I'll see you in the next lesson.